In this video, I want to give you a brief introduction to operational amplifiers or op-amps. So in order to be able to have a more in-depth idea about how op-amps work or how they are designed, you need to know more about electronic devices such as diodes and transistors. But if that is the case, and since this is an electrical circuit course and not an electronic course, why we still talk about operational amplifiers? So the first reason is that there is no need to fully understand how op-amps work to be able to use them. So without knowing what's happening inside op-amps, it is still possible to use them for designing some of the circuits that can be very useful for us. The main reason for that is that you can design circuits using op-amps by only knowing what is happening on the terminals. So if you know the terminal behavior of op-amps, you practically can start designing circuits with them. So even though that terminal behavior is based on some simplifying assumptions, but those simplifying assumptions are true most of the time. So that's one of the main reasons that we will be discussing op-amps here. So based on that, it's possible to combine op-amps with resistors to design circuits for scaling or amplifying, summation, sign changing, and subtraction of signals. Also, if you include inductors and capacitors, something that we will discuss at later lectures, you can design circuits that are able to integrate or differentiate signals as well. So that is a very interesting application of op-amps. So now that we have this out of the way, let's just go over a general overview of an op-amp. So the figure to the right, which looks like an 8-legged centipede, that is the general description or like the general depiction of an op-amp. So as you can see, we have 8 legs or 8 inputs. The first one, we call it the offset null. Then we have the inverting input, then the non-inverting input, then we have the V subscript negative or the negative power supply. We have another offset null, we have output, we have the positive power supply, and then finally we have NC, which is short for not connected. So this is the general depiction of MUA741 op-amp, which was introduced by Fairchild Semiconductor in 1968. So as I went through, we have 8 terminals for this op-amp. So we have the most important terminals to be the inverting input, the non-inverting input, the output, the positive power supply, and the negative power supply. So these are the 5 terminals that we will be using for this course. The offset null terminals are used for compensating the performance degradation, which happens over time with these operational amplifiers and any other circuit component. And the NC is basically not connected anywhere inside the unit. So this is, you would say, a circuit schematic of the op-amp or the IC, integrated circuit schematic of an op-amp. But we usually don't use it in our own circuits or designs. So the way that we represent op-amps in our circuit is something like this. we have a triangle with the 5 main terminals that we will be using. So we have the non-inverting input signified by this plus sign. We have the inverting input signified by this negative sign. We have the positive and negative power supplies. So as you can see, we don't have any positive or negative sign for these two. That's because we don't want to confuse you or ourselves with having more than necessary positive or negative sign. But usually the common practice is that the terminal that we represent on top, so this one, that is representative of the positive power supply, and the one that we show in the bottom of the op amp, that is representative of the negative power supply terminal. And finally we have this output terminal as well. So usually what happens, we don't put the name of the terminals in our design too. So this is the common shape and schematic that you will see in the circuits. So we have the non-inverting input signified with this positive sign, the inverting input signified with this negative sign. We have the positive power supply. We usually name it V positive, and then we have the negative power supply. We name it V negative, and then finally we have the output terminal. So this positive and negative power supply terminals, they are responsible for turning this op amp on, right? So the internal components of the op amp need to have some direct current power provided to them at all times for the circuit to be running. So without those, you basically cannot use an op amp. So in this video, we went over the basics of op amps. We saw different representations of op amps, and we also saw the terminals that usually any op amp has.